Hello students, today I am going to discuss about indefinite integration, method of substitution, and going to discuss about some problems. Okay, so theory part was given earlier, check that video and then watch this video. And I am going to provide here some interesting problems from NCERT books and some various other books. I'm going to provide some content here. So without wasting any time, I'm going to start today's session. The first problem is integration dx by under root 1 minus cos 2x. Dx by under root 1 minus cos 2x. So what will be the result here? In this integration, we know that will be dx by under root 1 minus cos 2x means 2 sine square x, 2 sine square x. So that will be 1 by root 2 outside of the integral part, and dx by sine x. Dx by sine x. That's it. Very easy. Because we all know that cos 2x equals to 1 minus 2 sine square x. So 2 sine square x will be 1 minus cos 2x. And that was given here. So that will be 1 by root 2 integration cosec x dx. And we all know that the integration formula of cosec x is log mod cosec x minus cot x plus c, where c is the integral constant or integration constant. So that's our first problem. Our second problem is something like this: dx by root under 1 plus cos x. Similarly, we can write that dx by root under 1 plus cos 2x will be 2 cos square x by 2, right? We all know that now. Cos 2x equals to 2 cos square x by 2 minus 1. Hence, 2 cos square x by 2 will be 1 plus cos x. Very simple. So, from this line, we can say that 1 by root 2 integration dx by cos of x by 2. Now, 1 by root 2 cos x by 2, after it says 1 by cos x by 2, you all know that is sec x by 2. Sec x by 2 dx, and integration of sec x by 2 will be log mod tan pi by 4 plus x by 4 here. Why? Plus c. Because we all know that integration of sec x, there are two formulas actually. First one is log mod sec x plus tan x plus c, and the second one is log mod tan pi by 4 plus x by 2. But here this is x by 2. So we need to write actually log mod tan pi by 4 plus x by 2, because here we need to consider x as x by 2. So that will be x by 4, and total divided by 2. Total divided by 2, because there's a x by 2, there's a coefficient with x, and that is half. So we need to write 1 by 2 root under 2 log modulus tan pi by 4 plus x by 4 plus c. That's it. That's our problem. That's our problem. Second problem, that's our second problem. After that, we move on to the third problem. The third problem is something like integration root under 1 plus cos 2x divided by 1 minus cos 2x. Very similar to the earlier one, and that will be root under 1 plus cos 2x. We all know that is 2 cos square x, and that one is 2 sine square x. So after integrating, we will get integration cot x dx, and we all know that the integration formula of cot x is log mod sin x plus c, where c is our integration constant. So that's our third problem. Now the fourth problem, we are going to move on to the fourth problem. Fourth problem is something like this: e to the power 3x dx, e to the power 3x dx divided by e to the power 3x plus 1. We need to substitute e to the power 3x plus 1 by t. Hence, that after differentiation, we will get 3 into e to the power 3x dx. That will be dt. So, e to the power 3x dx, that will be 1/3 of dt. Now, from this result, that will be 1/3 of dt, e to the power 3x dx totally will shifted by transformed by 1/3 of dt. So that will be 1/3 of dt, and the denominator part will be just t. So dt by t, we all know that that is log t, log mod t, and 1/3 of log mod t plus of c. That's it. Our fifth problem is integration sec x tan x, integration sec x tan x dx, sec x tan x dx divided by sec x tan x dx divided by 3 sec x plus 5. You need to consider 3 sec x plus 5. 3 sec x plus 5 equals to t. Now differentiate it. 3 into differentiation of sec x. Tell me. That will be sec x into tan x, right now. Sec x into tan x, and the differentiation part of 5 will be 0. Hence that will be 3 into sec x tan x dx, that will be dt. So sec x tan x dx, sec x tan x dx, that will be dt by 3, dt by 3. So the total result will be dt by 3, 3 will come out, and 3 sec x plus 5, we are considering it as t. So that the result is 1/3 of dt by t, and hence the result will be 1/3 of log modulus t plus c, where c is our integral constant. So that's our fifth problem. After that, we will move on to the sixth problem. Sixth problem is integration dx by x into 1 plus 3 plus log x, 3 plus log x. That's our problem. Actually, it was given here. So we need to consider 3 plus log x as t. After considering 3 plus log x as t, the differentiation part will be, differentiation of 3 will be 0, and differentiation of log x will be 1 by x into dx, and that will be dt. So dx by x will be dt here. So dx by x, that will be dt here. So after computing dx by x as dt and 3 plus log x as t, we will get the standard integral formula, and that will be log mod t plus c. Log mod t plus c, and we all know that t, the value of t is 3 plus log x, 3 plus log x. So the answer is log modulus 3 plus log x plus c. Now we'll move on to the seventh problem. Seventh problem is something like e power x plus 1 divided by e power x plus x dx. Here we need to consider e power x plus x as t. You need to consider e power x plus x as t, and the differentiation will be e power x. Differentiation of x will be 1 into dx, and that will be equal to dt. So e power x plus 1 into dx will be substituted by dt. So we are writing dt here, and e power x plus x will be substituted by t. So the result will be dt by t, integration of dt by t, and that will be log mod t, log modulus t plus c. And we all know that value of t is e power x plus c. That's our problem actually, where c is the integral constant. Now look at the next problem. That will be our eighth problem. Eighth problem is integration 1 by x log x, 1 by x log x dx. You need to consider log x as t, and from this relation you will get differentiation of log x will be 1 by x dx, and that will be dt. So dx by x part will be transformed in dt, and the log x part will be converted into t. So that's dt by t, and that's the standard integral formula, log modulus t plus c. And we all know that value of t is log x. So the answer will be log modulus log x plus c. That's our problem. Achha, wait a minute. I'm going to move on to the second problem of today. That was actually, I've made a mistake here. Just note it down. Just note it down. I've made a mistake here. I was thinking about that problem actually. Actually, it will be 1 by 2, right? So 1 by 2 will move on to the numerator part, and that will be root 2 into log modulus 10 pi by 4 plus x by 4. Sorry for that. Okay. So now move on to the next problem. That will be our ninth problem. Ninth problem is something like, ninth problem is integration cos x dx total divided by 2 plus 3 sin x. 2 plus 3 sin x. Here you need to consider 2 plus 3 sin x as t. You are substituting 2 plus 3 sin x as t. So that will be, after differentiation, that will be 2 will be 0, and that will be 3 into cos x into dx equals to dt. Hence cos x dx will be dt by 3. So cos x dx, that will be dt by 3, and 2 plus 3 sin x is t. So 1/3 of log modulus t, that's our formula, and plus c is the integration constant. So that result will be, final result will be 1/3 of log modulus. Value of t is 2 plus 3 sin x, 2 plus 3 sin x. We're putting the value of 2t, and that is 2 plus 3 sin x plus c. C is the integration constant. Now the next problem is number 10. Number 10 is integration 1 minus sin x divided by x plus cos x dx. Very easy problem. Just write x plus cos x as t and differentiate it. Differentiation of x will be 1, and differentiation of cos x will be minus of sin x. So 1 minus sin x into dx, this is equals to dt. So 1 minus sin x dx, this is equals to, this part will be substituted by dt, and x plus cos x will be substituted by t. Again the same formula, log mod t plus c, and you all know that value of t is x plus cos x. X plus cos x. So the answer is log modulus x plus cos x plus c. Very easy problems, a typical pattern, actually dx by x pattern, problem of the pattern of dx by x pattern, and after substituting the some particular area, we are getting the same pattern every time. That is integration dt by t, and that's log mod t. Now we are going to move on to our next problem, and that is our problem number 11. Problem number 11 is something like e power 2x divided by e power 2x minus 2 into dx. And we need to consider e power 2x minus 2 as t, and you need to differentiate it, and that will be 2 into e to the power 2x into dx, because differentiation of 2 will be 0, we all know that, and differentiation of t will be dt. So e to the power 2x dx will be dt by 2. Very easy. So e power 2x dx will be substituted by dt by 2, and e power 2x minus 2 substituted by t. Hence, again the same result, and that is the formula of log mod t plus c. And we need to put the value of t here, and the result will be e to the power 2x minus 2 plus c. So that's the problem. After that, we are going to switch on to the next problem, 12th problem. 12th problem is something like this: integration 2 cos x, 2 cos x minus 3 sin x, total divided by 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x, 6 cos x plus 4 sin x dx. That's our next problem. So what we need to do from this thing, we need to take common 2 from the denominator, and the result will be integration 2 cos x minus 3 sin x total by 3 cos x plus 2 sin x dx, right? And you need to consider 3 cos x plus 2 sin x as t again the same format, and you need to differentiate it, and the result will be the same, minus 3 sin x, because differentiation of cos x is always minus sin x and differentiation of sin x is cos x. So the result is this 2 cos x minus 3 sin x dx, this is equals to dt, and that is our numerator part, and that's going to be 1 by 2 integration dt divided by t, and the result will be half into log mod t, half into log mod t plus c. That's our problem. So problem solved. Again, a problem has been solved. Next, we are going to the 13th problem. 13th problem is integration cos 2x, integration cos 2x plus x plus 1 total divided by x square plus sine 2x, x square plus sine 2x plus 2x. A similar pattern of problem. We need to consider x square plus sine 2x plus 2x as t, and you need to differentiate it. Differentiation of x square will be 2x, differentiation of x square will be 2x, sine 2x, differentiation of sine 2x is 2 cos 2x, and differentiation of 2x is only 2 into dx, and this is equals to dt. You are taking 2 out of it, and 2 into x plus cos 2x plus 1 into dx equals to dt. Hence, x plus cos 2x plus 1 dx, this is equals to half into dt. This is equals to half into dt. So, you need to substitute this one by half dt, and the denominator part will be represented by t actually. Again, the same format, half into log modulus t plus c, and we know that the value of t is here. Value of t is here, x square plus sine 2x plus 2x plus c, where c is the integration constant. So that's our 13th problem. After that, we'll move on to the next pattern of problem. Next pattern is, it's our 14th problem. 14th problem is something like this: integration cosec x dx divided by cosec x dx divided by log tan x by 2. Log tan x by 2, that's our problem. So you need to consider log tan x by 2 as z here, z or t, whatever may be. So differentiation of log tan x by 2 will be very easy, 1 by tan x by 2 it will be, into differentiation of tan x by 2 will be sec square x by 2, and differentiation of x by 2 will be 1 by 2 dx, and differentiation of z is dz with respect to z actually. So that will be 1 by sine x by 2, sine x by 2 by cos x by 2, cos x by 2 into 1 by cos square x by 2 into 2 dx equals to dz. Now, after cancelling cos x by 2, we will get this result, dx by 2 sine x by 2 into cos x by 2 equals to dz, equals to dz. So, the result will be dx by, we all know that 2 sine x by 2 cos x by 2 is sine x. So, dx by sine x, that's equals to dz. Hence, that will be cosec x dx, cosec x dx, this is equals to our dz. Now you need to substitute cosec x dx as dz, and the lower part will be denoted by z. So the actual result will be here same, log modulus z plus c, and z is our log of tan x by 2, log of tan x by 2 plus c, log of tan x by 2 plus c. Okay, so that's our 14th problem. Now we will move on to the 15th problem. 15th problem is something like this: integration cosec square x divided by 1 plus cot x. 1 plus cot x. Very easy problem. Once again, a very easy problem. 1 plus cot x, you need to consider 1 plus cot x as z. You need to differentiate it. Differentiation of 1 will be 0. Differentiation of cot x will be minus cosec square x. Minus cosec square x dx, that will be dz. So cosec square x dx will be minus of dz. Hence, that will be cosec square x dx will be minus of dz. So that will be minus of dz divided by z. Now the same formula, log mod z, we are going to apply here, plus c, and you need to put the value of z here. The value of z is 1 plus cot x, hence this is our answer. Final answer is this. After that, we will move on to the 16th problem. 16th problem is something like this: integration sine 2x dx divided by a square plus b square sine square x. That's our problem. You need to consider the same old thing, a square plus b square sine square x as z, and you will get the differentiation result as 0 plus b square fixed sine square x. Differentiation will be 2 sine x into, by applying chain rule, the differentiation of sine x will be cos x into dx, total into dx equals to dz. Now we all know that that will be b square into sine 2x. b square into sine 2x dx, this is equals to dz. So sine 2x dx is equals to dz divided by b square. So we are putting the value of sine 2x dx, that is dz by b square, and a square plus b square sine square x is represented by z here. So the result will be 1 by b square into log modulus z plus c, and the total result will be 1 by b square log modulus a square plus b square sine square x plus c. That's our another problem, 16th problem. Next we will move on to the 17th problem. 17th problem is something like this. The formula, the problem is sec x, integration sec x divided by sec 2x. Integration sec x by sec 2x. You just need to reverse it. That is actually you need to write 1 by sec 2x as cos 2x, and you need to write sec x as 1 by cos x. So the result will be cos 2x by cos x, and we all know that cos 2x is 2 cos square x minus 1. 2 cos square x minus 1 divided by cos x. After splitting this result, the step we will get that 2 into integration cos x dx. That's our first integral, and the second integral will be integration dx by cos x. Integration dx by cos x. So integration of cos x, we all know that sin x, and dx by cos x will be integration of sec x dx plus c1. C1 is an integral constant. Now 2 sin x and integration of sec x, we all know that that will be integration of sec x will be log mod sec x plus tan x. Thank God, finally a different type of problem we are approaching here. Oh my God, it was so boring. Same type of problem. We are doing same type of problem. 16 problems were there which was of same type of.